Hey everyone, welcome to Philip in the Cloud. Today we're going to talk about how to use some of the convenience functions that we brought to backends like DuckDB and Polars to Snowflake. So that's things like read CSV, read Parquet, and read JSON. All right, let's get into it. First, I'm going to import interactive ibis things. We're just going to turn on interactive mode, and so we can look at tables, kind of the first few rows as they show up from the computation. Now let's just take a look at what the existing functionality looks like for the non kind of cloud-based backend. So we can connect to just a DuckDB instance by saying DuckDB process by saying ibis.duckdb to connect and calling that. And now we've got a bunch of like read foo functions: read CSV, read delta, read JSON, read Parquet. Most of these we're not going to talk about. We're going to talk about read CSV, read JSON, and read Parquet. Those are probably the three most common data engineering and data science formats that people are using today, and we support them in IBIS. So you can do things like, let's just pull in some of the testing data we use when we're testing IBIS. So we've got that in a CSV folder. I'm in the IBIS repo right now, so that'll all be there. We've diamonds. This is a data set from R, and we can just pull that up. Let's call it T, so I don't have to type a bunch. And DuckDB is going to read that CSV in and create a view from that. And we kind of got a table that we can start doing analysis with. We can analyze the carat or the price based on the cut or the clarity, etc. And so that's pretty nice. And we can kind of do the same. We have sort of mirror data sets in Parquet format that we can do the same kind of thing. We can say read Parquet. I can spell, and we get the same data. It's possible it's done it like in a slightly different order. It sort of depends on how DuckDB reads in the row groups of the file versus how the CSV is sort of read into a DuckDB. So that's pretty nice. And then finally, we can also read in like line delimited JSON, which is a relatively new feature in DuckDB, and we can get our data set that way. Each row is a JSON object, and that's interpreted as the fields of a table. So if we just take a look at that and cat the or let's say take the first um, couple rows of that data, penguins, ND-JSON. Let's say JSON. This might actually not be an end delimited JSON. Oh, okay, that's actually an array of JSON objects. So DuckDB deals with those too. Fun. We do have an ND-JSON here, so we can look at that as an individual rows, and so the first five, etc. And so each row is going to be parsed as a separate row in the final table output. This is super convenient. I've got a file locally. I want to do something with it. Maybe I've got a subset of my production data, or I just have a file locally that I got from a coworker I downloaded from somewhere. I want to do some data analysis. Typically, getting these files in whatever form they take into a cloud data warehouse like BigQuery or Snowflake uh, requires a series of steps that are non-trivial. In the Snowflake case, you need to first create a file format, which is going to say like, oh, this is a CSV file with these parameters. Maybe it's got a field delimiter, etc. And then you're going to associate that file format with a stage, which you also need to create. And the stage is basically a staging area for permanent or temporary files that you can then copy into a table. Depending on the file format, you then need to perhaps do a little bit of type inference on the file and then upload that and to get the schema from that file. You then need to upload that file, and then you need to copy that into the table that you just created from the type inference that you just did. So there's a lot of steps, and it's highly, highly specific to the database you're using, in this case, Snowflake. So let's see what we can do with that with IBIS. We've already imported things. Let's import OS so I can pull some credentials in without displaying them to the internet. We're just going to connect to the Snowflake URL. I'm going to list tables here. It's going to take a bit because there's some round trip network I/O that has to happen through Snowflake, and generally it's going to take a lot longer to do stuff in Snowflake than running on your local machine, and that's sort of the nature of the beast. You're using a big distributed cloud system. The way it's sort of set up is not entirely transparent, and that's just part of the product. Whereas with DuckDB locally or Polars or Data Fusion or Pandas or whatever, all those are just running on your local machine, so everything's close together. So it's just going to be much faster, and there's no network I/O. We're just looking at local files on those systems. So just keep that in mind when sort of playing around with this. And we can kind of we can do kind of similar things. Like in ibis 7, we'll have read CSV for Snowflake, we'll have read JSON, and we've got also read Parquet. So let's sort of try those out a bit. Let's look at read CSV first. So first, let's just pull in this diamonds table, and we're just gonna pass it like that, like we did with DuckDB. So like I said, it's going to take a bit. Okay, it's actually faster than I thought it would be, so that's great. And now we should have our table in Snowflake. Cool. You'll see the types inferred are a bit different, right? We've got caret, which is now a decimal 3,2. That's referring to the precision and scale. The precision is 3, which is the total number of decimal points, and 2 is the number of decimal. Sorry, not decimal points. 3 is the total number of decimal digits. 2 is the number of decimal digits following the decimal point. That's the precision in this scale. And then it's sort of done that for some of the other numbers as well. And Snowflake is going to actually, we're using Snowflake itself to do the inference. So we upload the CSV file, and then we say, hey, Snowflake, like, look at this file and figure out, like, tell me what you think the types are, and use that information to create a table, which is really convenient because, like, we don't have to do any of that on the ibis side. One sort of, it's not really a downside, maybe it's a trade-off, is that we're handing that over to Snowflake, and so it's going to have its own type inference algorithm for CSV files. And in this case, it's kind of inferring the most specific, most precise type it can for numeric types. Like, it's not saying, oh, it's just a float or a double, or it's an int64 or something like that. It looks like in some of the cases, like when it can detect it's an integer, it will, but if it's a floating point, it's going to infer it as like a very specific decimal type. So that's just a thing to note. Still though, pretty nice. You've got your table that you had in a CSV file, and you didn't have to think about these like 7 stages or 7 DDL commands that you need to run. ibis took care of that for you. So it's one line of code to read a CSV into Snowflake. And we can do a similar thing with Parquet. Let's take a Parquet file. Actually, first let's kick the tires a bit on read CSV. So maybe you have some other data that's a little bit messier. Let's look at some movie data from IMDb. We're going to upload, say, the title ratings. This is actually a TSV, and so it might be the case that your system, like if it's DuckDB or maybe Pandas, is going to figure out that there's tabs separating each field instead of commas. Well, let's see what happens when we do that with Snowflake. By the way, the other thing to note here is that ibis is creating a temporary table, much like it would be if you used Pandas to get a in-memory data frame, which goes away as soon as your process ends. As soon as your session closes with Snowflake, which will happen when you exit the interpreter, that temp table is going to be deleted. What's nice about that, or I guess some trade-offs are, since it's a temp table, it's native Snowflake storage, so it's going to be as fast as it could possibly be inside of Snowflake. If we did something like reading from a stage, then it's going to have to do all the type conversion and so forth right away, and so it'll be faster to register, faster to read the CSV and create a table you can do stuff with, but it'll be slower ultimately to do your analysis. That's a particular choice we made when implementing this. Let's see, is there anything else? No, that's it for that. Okay, so we got our TSV, and it's like a little wonky. It seemed to detect that the first row was a header, but all the fields are just a single string blob, and we probably want to like figure out how to deal with that. So one thing you can do is you can take a look at the create file format DDL, which I'll post in the chat, which is a sea of parameters that you can use to mess around with CSVs. So in this case, I want to try and tell Snowflake, like, hey, I know the field delimiter is actually tab. It's not comma. And let's see what it does with that. It should have 3 columns, tconst, average rating, and I think num votes is the third one. Let's see if it does sort of the, close to the right thing or the right thing. Can take a bit. All right. Cool. So it seemed to do something that was better than what it was doing before, now that I told it that the field delimiter is a type. So sometimes you've got some data that's messier than the typical CSV, or it's a TSV, or it's a pipe delimited thing, and so you may have to like look at those parameters in that link, and then see how sort of you can kind of pass them as is into the ibis read CSV. We're going to turn those into the right DDL for you. All right, let's move on to read parquet. Read parquet. We kind of do the same thing here. We've got our diamonds data set, and that's actually faster. The parquet file is probably smaller than the CSV file for diamonds. And so let's take a look at what that did. Cool. Parquet is easier to work with than CSVs and generally going to be a better choice if you need long-term storage or fast storage. CSVs carry no type information, so they require type inference, and there's all sorts of annoying problems with CSVs, and Parquet is generally going to be a better choice. Systems like Snowflake and DuckDB can without looking at the data, get the type information for each column. And so in this case, it's actually much more precise, right? Parquet encodes the type for each column as a very precise thing. So in this case, caret is float 64. It's not a decimal 32 like it was when we told Snowflake to figure out the type. Same for all the other floating point columns. Parquet does support decimal, but it's not encoded that way in the file, so it doesn't show up that way. You'll also notice that it was faster to actually like do something with that file because it's likely smaller than the equivalent CSV. I could be wrong, but let's just verify that or check to see if that's actually going to make me put my foot in my mouth. Testing data, Parquet, diamonds. Okay, so it's 508K for Parquet, and then we've got CSV, diamonds, CSV. Okay, so it's roughly 5 times smaller. The Parquet file is roughly 5 times smaller, so that's pretty nice. I think that's with the default compression. There's other compression schemes you can use to make it smaller, even smaller than that, depending on the data. Anyway, that's in part responsible for the faster uploads. Finally, we have read JSON. And let's look at ND-JSON. I believe Snowflake can read both the array of objects and the line delimited JSON, but we're just going to look at ND-JSON for now. This is the penguins data set, which you can access from ibis examples, which is pretty nice. Let's see. Okay, so that was pretty quick. I think this data set is relatively small. I think it's got like 300 rows, so it's tiny by comparison to the things people are usually slurping up in Snowflake. It's 56K, so it's a tiny data set, and we can even count the rows. So 344, not huge. But it's really convenient to upload that into Snowflake and start doing stuff with it. Now I'm going to try something that I actually have not run today. I ran most of these examples. I don't think I actually used these specific Parquet files earlier when I was testing. But there's actually a feature in ibis that lets you set the default backends. So I'm going to set the default backend to the Snowflake backend. And there are a few APIs in ibis that when you use them, if the expression does not have an attached backend, it's going to use this default backend to do the computations. So if you don't want to always connect to a thing, or you have a thing that you always connect to and you don't really want to sort of have to specify that everywhere, especially if you're dealing with a lot of mem tables and data frames, that can be convenient. So one API where this is used is our examples. So we've got the examples module in the namespace is X. That's coming from ibis.interactive. And since the examples module will use the default backend to read in examples. And it's going to use read CSV and read Parquet where appropriate. Now that I've set that to the Snowflake backend and we've implemented read CSV and read Parquet, we should actually be able to transparently use Snowflake to play around with all of ibis's examples. So let's throw something. Let's look at penguins, because that's actually one that we think is probably going to work. If it doesn't work, it's going to explode. I'm going to have to put my foot in my mouth. Let's see what happens. All right. It looks like it uploaded. That's pretty cool. I'm not actually sure if it used the Snowflake backend. Let's see if that actually is the case. T dot, how can we look at that? Let's turn off interactive mode. Not operations. Config, no. Options. Okay, interactive false. T. So we should actually, we've got this database table here, which is like generating a sort of temporary name. And we actually should be able to see the source, which is the Snowflake backend, which is pretty sweet. That means things are sort of looking good. And if we list tables, we should be able to see this k DAS ob cdr whatever thing here above. Okay. It looks like that table is actually in our Snowflake database, which means we did successfully read that file, that penguins file, CSV, that example, into Snowflake. And you can see a bunch of other stuff that we've been dealing with today, like when we read that Parquet file, and the JSON, and the other CSV files, and we read in a mem table apparently somewhere. Don't remember quite doing that, but maybe we did. I suspect what's happening here is we're actually reading this in with pandas and then uploading that as a Parquet file, which is sort of the fallback. But it's pretty nice that that works. So we're going to actually have to implement. We're going to have to actually add Snowflake to the list of backends that's sort of natively allowed to do it. Anyway, please enjoy. Please try it out. ibis-project.org, github.com/ibis-project/ibis. Those are all the places that you can find IBIS on the internet. This is Philip in the Cloud. Hope you enjoyed the session. Please tune in next time. Thanks everyone for joining. See ya.